In this video tutorial, I will demonstrate the use of a Punnett square for solving dihybrid cross problems that appear in undergraduate general biology courses. The first step in solving such a problem is to carefully read the question to extract as much useful information as possible. While doing this, I keep in mind that my goal in a dihybrid cross is to translate a phenotype to a genotype, or vice versa. In the example given here, there are 2 traits and 4 total phenotypes described. This identifies the problem as a dihybrid cross. The first trait is skin pattern. I will represent the recessive allele, which is unfreckled skin, with a lowercase f. Please note that this phenotype can be the result of only one genotype, homozygous recessive. I will represent the dominant allele of skin pattern, which is freckled skin, with an uppercase F. In contrast to the recessive phenotype, please note that this phenotype can be the result of 2 different genotypes. First, a homozygous dominant genotype will result in a dominant phenotype. And second, a heterozygous genotype will result in a dominant phenotype. Now, let's take a look at the second trait, hair color. The same rules apply, but in this case, I will represent the recessive allele, which is red hair, with a lowercase b, and the dominant allele, which is brown hair, with an uppercase B. Next, I'll make a list of the phenotypes provided by the question. In this case, we know the phenotypes of 8 offspring. 2 of the offspring have unfreckled skin and red hair. This is a double recessive phenotype that can only be described by a single genotype, homozygous recessive skin color. Two additional offspring have freckled skin and brown hair. We thus know that the genotype of each trait must include at least one dominant allele. However, we do not yet know the identity of the second allele of each trait, which could be either recessive or another dominant allele. I will represent this uncertainty with a question mark. Another group of 2 offspring have freckled skin and red hair. The genotype of these offspring must include at least one dominant allele for skin pattern and must be homozygous recessive for hair color. The final group of 2 offspring have unfreckled skin and brown hair. The genotype of these offspring must be homozygous recessive for skin pattern and must include at least one dominant allele for hair color. Now that I can see what I'm dealing with, I want to organize these offspring into a Punnett square appropriate for a dihybrid cross. This will typically be a table with 4 rows and 4 columns, each cell representing a single offspring. Then, I calculate the ratio of genotypes in the offspring, which is 1 to 1 to 1 to 1. To make this fit into a Punnett square, I need to scale this ratio to include 16 theoretical offspring. So, 4 to 4 to 4 to 4. Let's fill in the columns of the Punnett square with the information I've already written out concerning the 4 genotypes. In the right-hand column, I will enter the 4 homozygous recessive offspring. I will then enter the remaining 3 groups of offspring in columns 1 through 3. You should immediately notice the power of the Punnett square. It simplifies the process of deduction required to solve difficult dihybrid cross problems like this one. For instance, once I assume that one allele for each trait comes from one parent, I can begin to deduce the parental genotypes. In this scenario, I will start by noticing that at least one recessive allele for each trait must come from each parent. This is based on column 4. Next, I use that information to complete the Punnett square by looking at what I now know about each parent. So we have a recessive skin pattern, recessive hair color, gamete for each parent. Now I go down that particular row 4 and notice that the parent on the vertical axis must have recessive alleles in all gametes. With the information I've just gained about the parent in the vertical axis, I can fill in the remaining genotypes for the 16 offspring. Looking at this table, I also notice that there are several dominant alleles that remain unaccounted for. Since I have already determined the gametes created by the parent in the vertical axis, I know that these dominant alleles must have come from gametes of the parent in the horizontal axis. Note that all of the alleles that I'm writing out now have been determined based on the offspring's genotypes. Finally, I need to complete the question by explicitly writing the genotype of each parent. I can do this by examining the individual gametes provided at the beginning of each column or row. In this case, I can see that the parent on the vertical axis has only recessive alleles for skin pattern and for hair color. Thus, that parent's genotype must be homozygous recessive for each. The parent on the horizontal axis has a dominant allele and a recessive allele for skin pattern, and a dominant allele and a recessive allele for hair color. Therefore, that parent is heterozygous for both. Again, the final step is to explicitly write this cross. Double heterozygote crossed with a double homozygous recessive. And that's the answer to this challenging dihybrid cross.